Hello everyone, in this video I'm going to discuss one-to-one function, and by the way this PowerPoint presentation is already uploaded on my website www.paulgerelsantos.weebly.com under General Mathematics Learning Materials. So for our review, what is the previous lesson? We discussed graphing rational function as well as how to determine the intercepts, zeros, and asymptotes of a rational function. So what is a function again? A function is a set of ordered pairs whose a single or an element of the domain is paired to exactly one element of the range. And what is the vertical line test? If you're given the graph of uh, a relation, we can say that this is a function if it satisfies the vertical line test. So the vertical line test tells us that um, the graph of a function intersect a vertical line or any vertical line at exactly one point. So if a graph intersects a vertical line at 2 points, then it is not a function. Okay? For our objectives, we must represent real-life situation using one-to-one function. That is the first one. We must also define a one-to-one function. And we must illustrate the horizontal line test. And because this horizontal line test is like the vertical line test, it is used to determine if a function is one-to-one. So let us have some examples. We have here pairing LRN to a student. And we all know that this one is a one-to-one function. So why is it a one-to-one function? Because a unique LRN is given to a single student. A student cannot share, or two students cannot share a single LRN. Or two LRN cannot be given to a single student. Okay? Only one LRN per student. For students, for a student, he can only have a single LRN. Okay, for the second example or non-example, this one is a non-example, pairing a number to its square. A number is paired to its square. Okay, it seems to be one-to-one, but if you're going to think of another number, which is, for example, 2 is paired to 4, but we all know that negative 2 is also paired to 4. So 4 is paired to 2 and negative 2. That is why this one is not one-to-one. We can say that it can be many to one. Okay? There are some this one is many to one. Okay? For number 3 is pairing a student to his mother. A student has only one mother, but a mother may have children who are also students. So a student to his mother, it seems to be one-to-one, but mother can also have many students or children who are students. So it is not one-to-one, it is also many-to-one. For number 4, pairing a vehicle to its plate number. Uh, so we all know that a vehicle can only have a single plate number, and a plate number, a unique plate number, is given to only one vehicle. No two vehicles can have the same plate number. Okay? No two vehicles can have the same plate number. And no vehicle can have more than one or two or more plate numbers. Okay, for number 5, This one is not one-to-one because a jeepney fare for me can be 9 pesos, 10 pesos, 11 pesos. Okay, it depends upon the it depends upon the distance. Okay, a person can also have the same jeepney fare with me. Okay, we we can say that we both pay 9 pesos for our fare. So that makes it not one-to-one. It can be many to one. To give you an illustration of a one-to-one function, okay, the only one-to-one function among these three is the first one. So as you can see, the element of x is paired to exactly a single element of x is paired exactly to a single element of y, and vice versa. A single element of y, an element of y is paired exactly to one element of x. So this is one to one. But the other one is, the second one is many to one. 5 and 7 are paired to 1, so many to 1. While for the third one, we have 7 is paired to 11 and 13. That makes it 1 to many. So in the first place, that is not a function. So this is not, the second and the third are not one-to-one functions. To define a one-to-one function, the function f is said to be one-to-one if for all x sub 1, x sub 2 in the domain of f, if x sub 1 is not equal to x sub 2, so those x sub 1 and x sub 2 are not the same, then f of x sub 1 should not be equal to f of x sub 2. It is equivalent in saying, or to say, that if f of x sub 1 is equal to f of x sub 2, then x sub 1 is equal to x sub 2. Meaning, any y values is never paired with two different x values. Now, to give you some examples, let us determine if f is one-to-one function. So for the first one, we have f of x equals x squared. Okay, in looking at this, I may say that this is not a one-to-one function. Later, we are going to prove that. And for number 2, this one is a one-to-one function. We'll also prove this. F of x equals 2x plus 1. So for number 1, we have f of x equals x squared. We all know, based on the definition, that if f of x sub 1 is equal to f of x sub 2, we must show there are no counterexamples that x sub 1 is equal to x sub 2. Okay, based on the definition or evaluating this function, f of x sub 1 is x sub 1 squared. We just replace x by x sub 1. For the second one, we have x sub 2 squared. We just replace x by x sub 2. Okay? We just evaluate the function. And we can say that negative 2 squared, which is equal to 4, is equal to 2 squared, which is also equal to 4. But the case is our x sub 1, negative 2, is not equal to our x sub 2, which is 2. That is why, okay, since there are two values for x in a given y, the function is not one-to-one. Okay? We just proved that since, or if we have f of x sub 1 equal to x is equal to f of x sub 2, we arrive at x sub 1 not equal to x sub 2. Therefore, our conclusion is this one is not a one-to-one. For our second example, or second practice exercise, we have f of x equals 2x plus 1. Okay, f of x sub 1 should be equal to f of x sub 2. Okay, 2x sub 1 plus 1 is equal to 2x sub 2 plus 1. Okay, we just evaluate a number 2 or the second function. So we just replace x by x sub 1 in the left. On the right, we just replace x by x sub 2. Okay, so subtracting both sides by 1, we have 2x sub 1 equals 2x sub 2. And dividing both sides by 2, we have x sub 1 is equal to x sub 2. We just proved that if f of x sub 1 is equal to f of x sub 2, x sub 1 is equal to x sub 2. Okay, based on the definition of a one-to-one function, okay, this is a one-to-one function because we are able to show that if f of x sub 1 is equal to f of x sub 2, x sub 1 is equal to x sub 2. So what is this horizontal line test? A horizontal line test tells us that a function is one-to-one if each horizontal line does not intersect the graph at more than one point. To give you some example, okay, try to look at this. The first figure on the left is the graph of f of x equals x squared. Okay, the function earlier. And as you can see, the horizontal line intersect the graph at 2 points. That is why it is not a one-to-one function. We also proved that earlier. For number 2, or for the second one, as you can see, any horizontal line intersect the graph at exactly 1 point. So, if that's the case, that's a one-to-one function. And by the way, that is the graph of the second example earlier, second function. So this question is for you. What is the difference of one-to-one function to the other function? Okay, I'm not going to answer this, no? Perhaps you can answer this some exercise on your own. Okay, this will be the, by the way, this will be the first part of our lesson in one-to-one function and inverse function. And stay tuned to our channel because there will be another video that will discuss inverse of a function.